Hello and welcome to another video, this time on some complex geometry questions. These are a couple of questions which Corridor once again has sent me. He's kept me busy this bank holiday weekend, he really has. I like these though, actually. I would describe them as AS complex numbers rather than A2 because it isn't actually about anything difficult like roots of unity or just any of the complex geometry you tend to do when you're in the A2 textbook. Things like complex numbers of rotations. When you multiply by e to the I theta, you're just going to turn for an angle of theta, etc., etc. This one's more about the locus questions. When you're dealing with a path of points. Now, okay. Firstly, when I look at that, I think that is a circle, and it's a circle centre 4 plus 4i, and radius 2 root 2. Remember that this isn't r squared, it's just r. That's sometimes a mistake people make. So I'm going to sketch it, yeah, and I'm going to try and use it to prove that. Essentially, though, it is just going to be lots of geometry, so it's going to be difficult me doing this nicely as well, unless I draw a really good diagram. So I'm trying here, people, I'm really trying. Maybe I should have used GeoGebra to actually draw it, but you wouldn't have that luxury, obviously, in school, so bear that in mind. So, okay, right. That's there. Let's say this is 4 here. This is obviously the imaginary axis. This is the real axis. Okay, and we've basically got a circle coming round like that. And that shows you, can I make this very clear as well, that when we write down something like that, the reason why it describes a circle is because Z basically represents all the complex numbers which lie on this circle, yeah? Because what you're saying is, basically, there's a complex number which when you subtract from it 4 plus 4i, and essentially that moves you from the origin up to here, and find the length of that distance, yeah? So this is basically the length from Z to 4 plus 4i, because modulus means finds the length should be 2 root 2. And that's why it makes a circle 2 root 2. But my number one point I want to emphasize is Z lives on the circle. Call this one Z1, Z2, Z3, Z4. These are all possible values of Z which satisfy that equation, yeah? So remember, Z lives on the circle. That's what Z does, yeah? It makes sense of the last part of this question. Okay, so this is what we've got, and we've got to prove without a scale drawing or anything like that. You're not going to just draw it nicely. We've got to prove that that is true, that the argument of Z is stuck between here and here. Well, what's it actually talking about here? Well, the argument of Z, if Z represents all of these complex numbers which live on the circle, yeah, all of these complex numbers can be thought of as vectors, yeah, and what's more, they are position vectors from the origin, yeah. Let's take a value of Z down here, because that would be like a 4 minus 2 root 2i, wouldn't it? 4i minus 2 root 2i. Well, let's put it 4 minus 2 root 2i, like that, yeah. That's just going to be that value down there because the radius is 2 root 2. Take this particular complex number, which equals 4 plus 4 minus 2 root 2i, yeah? That satisfies that equation, yeah? Now, we're interested in the argument of all the complex numbers which satisfy that equation, which means, let me just get rid of some of those dots, that we want to find the maximum and minimum value of the argument of Z. Now, can you see that if you want to find the minimum argument, well, that's going to occur for a complex number which lives on this circle and is, as and has a smaller argument as possible when you draw it from the origin, yeah? And that's why we're interested in this angle here. Let's call this angle here theta. And then the maximum argument available is going to be happening for the complex number which lives on the circle there, yeah, because all the values of Z live on this circle and they all have different arguments. But can you see, if I take the argument of that number, for example, it's in between this angle and this angle. If I take the argument of this complex number, it's still in between. So can you see what I mean by when I say that's the maximum and minimum value of the argument of the Z's which live on the circle? That's what it is. That's what it represents. And so, let's do it. Now, you can do this obviously with a little bit of circle theorems, yeah. This should be a right angle because it's going to be tangent to the circle. Same with this one. So we get a lovely kite, and naturally the two triangles which you can divide the kite into are congruent. They're exactly the same shape and size. I could easily prove that using RHS if you like, or fairly obvious. I'll leave that. This is a radius, this is a radius, there's a side in common, and you've also got a right angle in there. It's essentially RHS, isn't it? Okay, so yeah, they are congruent triangles. So what I really want to do is I want to find the angle in here. Yeah, let's call this one alpha. Yeah. Now, do I know some of the lengths here? Well, I know that's 2 root 2 because that's the radius. Yeah. Now, remember that this is 4 plus 4i, the centre. Yeah. And so I can find the length of that line by doing 4 squared plus 4 squared square rooted. And that length is root 32. But root 32 is naturally 4 root 2. And so let's call it 4 root 2. Okay, now I can work out alpha, can't I? Because I can say, well, sine alpha, remember this is a right angled triangle, so I can use SOHCAHTOA, is going to be equal to opposite divided by hypotenuse. That gives a half, which is lovely. And so alpha is clearly 30 degrees or pi over 6 radians. If you hear some noise in the background, it's just my children. Okay, so I've got pi over 6 in here, so that's pi over 6 as well. And I can call this pi over 6. And I can say, hence, min value of argument of z is going to be equal to, well, that's pi over 6, that's pi over 6. And as this is all symmetrical, and that's down obviously at 45 degrees, we can work out theta by noting that that angle's also going to be a theta as well. And we can just do the whole angle here, pi over 2, minus 2 times pi over 6 halved, yeah? Divided by 2 times by a half, yeah? Can you see where I'm getting that from? It's because this whole angle is pi over 2, that's a pi over 6, that's a pi over 6, so double that, take it away from pi over 2 and then halve it because that represents 2 theta before you've halved it. Ollie, stay away from that. Sorry. Okay, so let's just work out what this is. That's pi over 2 minus pi over 3, halved. And that gives you 3 pi over 6 minus 2 pi over 6, that's 5 pi over 6. Sorry, pi over 6, I apologise, times by a half, which is pi over 12, yeah? And hence, the minimum value of argz is pi over 12. Then you can easily establish, as that's pi over 12, that we need to do pi over 2 minus pi over 12 for the maximum value of argz. Max value of argz is going to be equal to pi over 2, take away a pi over 12, which is 5 pi over 12, and I can say alas, well, not alas, that's a bad way of putting it probably, it's more for negative things. Okay, so hence argz is trapped between those two values. And it can be equal to them in the extreme case. Cool, so that's that one. Now this one, slightly more difficult, but similar in the sense that it's just about SOHCAHTOA, yeah? But it did take me a little bit longer in the morning, this. But I actually preferred these questions to all the other ones I've gone through, Corriday. So these ones were the easiest ones that you sent me, I would say. Yeah? Okay, let's do it. I still haven't done as well the, what was it, like a springs and strings question on Hooke's law. I need to do that for you still as well. Anyway, let's draw out a nice clear diagram again. Now, this is tricky to draw nicely. It gives you recommendations. It says draw this one, and draw this one, yeah, and for good reason, and immediately I was a little confused because I was like, okay, this one is basically, once again, it's along the line y equals x, if you like, and so let's call this im and re. Okay, right, so let's say this one's about here, yeah, you can think of that as, this one's going to be difficult to do really nicely because it's all about how nicely you draw it. So this is root 2 plus root 2i, let's just call it z. Yeah, and then if we draw w's down here basically, and this isn't a stream. If you as extreme, if you think about it, that's 1 across, root 3 across and 1 down, and that would actually make that angle pi over 6. If you're wondering how I'm getting that, basically a quick bit of tan in my head. Root 3, 1 theta, tan theta is 1 over root 3, so theta is going to be minus pi over 6, for if you're, if you're doing it as the argument should be stated, but I'm just talking about the actual angle from there to there here is going to be pi over 6. And here's W, yeah? Now, if you added Z onto the end of W, it would look something like this, yeah? It would be absolutely parallel to that. And so that one there would be Z plus W, yeah, because it involves basically going to Z, going to W, and then if I do this in another colour actually, let's do it. It's going to be quite hard making this diagram serviceable. Okay. This is Z plus W. Okay, right, let's try and do this. Now I'm going to have to get closer to this diagram to do this, because there's going to be a lot of angle arguments, yeah? Now firstly, let's go back to red. This angle here, going from there all the way down to the bottom, is pi over 4. Yeah? That's because this is just a 45-degree angle. Yeah, and it's because it's root 2 plus root 2i. Now, we can actually, if we kind of think about this like using alternate angles, yeah, we can realise, well, there's a z here, yeah, not this z, but there's a z angle, an alternate angle here, and so that's pi over 4. Similarly, I can work out this angle up here, because this is parallel to this one. I can see it's pi over 6. Yeah? And so the angle in between must be pi minus pi over 4 minus pi over 6. Now, I'll tell you what, let's just add up pi over 4 and pi over 6. You're going to get 6 pi over 4 pi 10 pi over 24, which is 5 pi over 12. Yeah? Okay, so we know that we need to do pi minus these two, which add to pi over 12. And so this is going to be 5 pi over 12, I think. Let's draw it nice and neat. 5 pi over 12. Cool. Now, what I was then thinking was, okay, what I really need here, I kind of guessed, this was a guess, I kind of thought, I bet in this question that little angle down there is going to be pi over 24. And my guess ended up being a very sensible guess, and it was absolutely correct. Now, the way I can prove that is I then started thinking about the lengths of the sides, yeah? So what's the length of this? Well, remember, was it root 2 or 2 root 2? I can't remember. Root 2 plus root 2i. So if it's root 2 plus root 2i, the length is just going to be root 2 squared plus root 2 squared square rooted. That gives you root of 4, which is 2. So that has a length of 2. That side. And now, what about W? What's the length of W? Well, W was equal to, was it root 3 minus I? And root 3 all squared is 3, plus 1 squared is 1, 4. This also has a length of 2, which means this side has a length of 2, which means this triangle I've drawn is in fact isosceles. Yes, that's what we need. So let's actually label it so the person marking our work can actually see what we're doing. If I call this A, and I call this point B, and I call this point C, I can say ABC is isosceles, and so both BAC and BCA are equal, and we can say that they equal, quite simply, 180 degrees in a triangle, so let's call that pi, but take away pi over 12, 5 pi over 12, and then halve it, yeah? And that's going to give us pi over 12 minus 5 pi over 12, 7 pi over 12, halve it, you're going to get 7 pi over 24. That's this angle here, 7 pi over 24. But it's also this angle from here to here. Let's do it in a different colour. From there just down to there is 7 pi over 24. Yeah? Let's remove that z plus w because it's kind of getting in the way now. Okay, so what has this told us? This has helped us to find this little angle down here, which I'm going to do in green. That's sort of whatever colour this is. If you do pi over 4, yeah, let's actually write to the examiner as well, let them know what we're doing. So to find angle, basically to find the argument of the blue line, should we give it a name? Let's call it alpha. Yeah. To find alpha, we just need to do pi over 4 minus 7 pi over 24. Yeah. And okay, pi over 4 is going to be 6 pi over 24. That's 7 pi over 24. Okay, I've done it the wrong way round then. Why have I done it the wrong way round? That's 6 pi over... Wait, does this... Have I just done my... Have I messed up my maths here? Let's actually quickly check. 5 pi over... Oh, look, 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 look. I can't believe that. I'm so sorry, Corriday. I'm doing this all the wrong way round. Look at this. I've got no doubt watching you would have spotted this. That's actually 7 pi over 12, isn't it? Because these two add to give 5 pi over 12. When I'm talking and doing maths at the same time, I often just make mistakes with the maths I'm writing down. Apologies, though. That's completely my fault. So as that's 7 pi over 12, that needs to be 7 pi over 12 in there. Remember as well, mistakes is something everybody does, and you have to work through your mistakes and get past them. I could see it at the end, couldn't I? Because that didn't make any sense. So we'll just correct it. Pi minus 7 pi over 12 is going to be 5 pi over 12. Half of it is 5 pi over 24. So the 7s and 5s are symmetric here in this sense, and so they will switch round. So that's 5 pi over 24. So we're actually going to be doing pi over 4 minus 5 pi over 24. Okay, hopefully everybody understands my fix there. I'm very sorry. Well done if you spotted it. If you were screaming at the screen, good for you. Yeah, we go. When we work through these questions, we can always see what we're doing wrong, which is nice. Okay, so we've now worked out this is 5 pi over 24. That blue one is 5 pi over 24. And now we should be subtracting it definitely that way round. And so we get 6 pi over 24 minus 5 pi over 24, which is pi over 24. Now, when I did this firstly, I didn't make that mistake. I just quite like to say that. But I had basically a very similar diagram, and I did all this. And as soon as I got that pi over 24, I thought, great, I now know where this is coming from. Now, how are you going to work out tan of pi over 24? Well, let's actually draw it, yeah? We've got z plus w here. Yeah, and remember we know what z plus w is because we had z and we had w. It will be, was it root 2 plus root 3 for the real part, and then root 2i minus I, so that will be root 2 minus 1i for the imaginary part. That tells me everything I need to know because I know that this is pi over 24, and I know the opposite, as it's the imaginary part, is root 2 minus 1, and the adjacent is root 2 plus root 3. And so I can now say tan of pi over 24 equals opposite, which is root 2 minus 1, over adjacent, which is root 2 plus root 3. Okay, now it's just a case of trying to turn it into their answer. So I'm going to times by root 2 minus root 3, top and bottom, rationalise the denominator. And that's going to equal, okay, on the top, right, firstly we're going to get minus 1 on the bottom. I don't remember getting, oh yeah, because I just drew it down the other way around. Right, okay. I'm going to get minus 1 on the bottom. I think I did everything more sensibly the first time I did this. Then I'm going to get 2 minus root 2 minus root 6 and then plus root 3. And that equals root 6 minus root 3 plus root 2 minus 2. Is that what they had? Something like that? Root 6 minus root 3 plus root 2 minus 2. Okay, so I hope that made sense. It's not as bad as it looks, that question. Provided you're happy drawing out these kind of diagrams, and provided you don't blunder like I did. But it's easy to spot because obviously when you're given the answer, you should know what you're looking for in the question, and that always helps you identify mistakes. Okay, hope that was useful anyway. Keep up the hard work. Exam soon. You can do it. You can do it. Bye-bye.